Hi everyone, my name is Jashi and this is my teammate Jenny. Today we're going to talk about our project FilmEMO. So our project FilmEMO is aims to build up a LLM-based tool by transfer learning to help people pick movie within few seconds. There are a few reasons inspire us to develop this application. First of all, we believe that reading common commands one by one and filtering out the noise, score, or review is time-consuming. Besides, review or score from single website may not comprehensive enough to represent the audience population. So different from the traditional way how we do the movie research, our FilmEMO system only asks the user to input the movie name they are interested in, and then the system will estimate a score of this movie based on its review sentiment analysis from various websites.
Okay, for the data collection, we have used two kinds of data source. One is IMDb comments dataset, and we have used the web crawler to extract top hot movies comments from the Rotten Tomato. And we only use the comments and the sentiment label in IMDb comments dataset, and we have manually labeled the comments we have crawled from the Rotten Tomato. And so our labels are negative, neutral, and positive. We have about 68,000 comments with labels. And we have done user surveys to, we have choose 3 movies and invite a group of people to watch and score these movies. And we have used these scores to compare with our scores, IMDb scores and the Rotten Tomato scores. And for the data processing, we have done a series of processing to improve the data quality, including removed all continuous space, non-alphabetic characters, and removed all emojis and special symbols and stop words. And we have done the tokenization, and then is a baseline model.
We'll dive into the architecture and the performance of our model. This is the baseline model. First, the baseline model will take the movie review. We will vectorize the movie review by the TIDF vectorizer into a vector, and then the classifier model we use the charge boost. The charge boost will classify, will predict the label of the movie review based on the vectorized vector. Yeah, here's an example how does our baseline model work, and here's the performance of it. So for our baseline model, we can predict around 86% of text movie review correctly. Unless respect to our FilmEMO model, it has 3 main components: the tokenizer and the feature extractor. We use the GB2 median portraying model from Hugging Face as our feature extractor, and then the last component is the classifier. Here's the structure of our classifier. Yeah, it's working as predict the label of our input review. Here's the performance of our EMO system. It can predict 90% of movie review. Yeah, comparing with the baseline model, the accuracy of our FilmEMO model is slightly higher. However, as you guys can see, from the confusion matrix, our model did much better on distinguish on the negative movie reviews. And also, we also find that adding the dropout layer to our model can significantly enhance the model performance, like by reducing the overfitting.
Okay, for the software, we have used the Python Flask as our framework to build our backend, and at the same time, we use HTML, CSS, JS to build our front end. And here is a simple architecture of our software, and we have prepared a demo for that. As you can see, the input is a movie name, and then we analyze, then we run the web crawler to get the top hot comments from the Rotten Tomato and IMDb, and then we do the data processing. Then we input each comments to the trained model to get the result, and then show the result Okay, here is an example. And we have got the audience average score and the critic average scores.
Where's your score?
These three scores are generated by our model, not from the website. And here is the
Yeah.
proportion. Yeah.
Yeah, I'm afraid you're done. You need to practice more to get done in time.
Okay.
Still reading so much. Okay, thank you.